kind of a problem probably with this card. Not the card, but this. There we go. And there we go. It should be better. Hello, 1, 2, 3. All right. So yeah, so Derek was suggesting that I could disable the sound in OBS and try to get it to release the devices, but I believe this is actually a separate setting, if I'm not mistaken. I think here in the audio you have, is it audio or maybe even advanced? I remember seeing this setting somewhere. There's alignment. Yeah, I'd have to look, but if I recall properly, there's a setting you have to check to tell it to release the device if it's not actually in the current stage or if it's not currently being used, which would definitely have solved my problem. Okay, I can't remember where this option is. I'll have to look a bit later. But thanks for the suggestion, Daru. That's definitely something I'll have to look into. Okay, so now let's get rid of this, and then let's try to tweak this guy so that this part here looks a little better. Okay. And then now let's show this guy again, and let us erase with maximum softness and even some alpha here. Yeah. So now this looks a little better. Oops. Last brush. Alright, and I'm going to go in here and I'm going to actually draw a line exactly like Daru suggested. And oops, wrong button. That is not quite the right thickness. Oh, that's not quite right either. Alright. Yeah, sorry I had to cut the stream for a bit there. It was even OBS crashed actually when I closed. The problem, it's kind of shameful, but I think what's going on is actually I know I have bad RAM in this computer, and every like so many hours of listening, my sound card just freaks out, and both the inputs and the outputs just kind of break up, and everything starts sounding robotic. So I wasn't able to test this because I won't monitor. I mean, the output is broken, so I don't know if the input still works, but I'm pretty confident the input from the microphone wouldn't have worked either. And unfortunately, my sound card won't let me reboot unless the driver's not in use anymore, and so OBS was locking the device and so on. So all right, now that we've got something that looks decent, let's see if we can't paint here. There we go. Bigger tolerance. Yeah, this is starting to work. Yeah, not quite, but there we go. Like that, maybe. Also, I wonder if I could actually denoise this somehow. Check it out, like using the median function and then a smaller radius. I think that's a good ticket actually. Let's try this. This guy will have more grain over here. I'll do the same thing on this layer. There we go. Okay, save this just for fun. All right. Is that right? What? Okay, okay. Do these actually connect? They do not. It looks like they do because there was crap on the PCB. But no. Alright, so this is wrong. Let me. Alright. Alright. You know what? Might actually gonna. I might actually just trace over this. There we go. Good enough. Same thing here. There we go. Awesome. There we go. Well, bad RAM, eh? I'm a brace hole. Yes, but there's only one bit out of 16 gigs that are apparently bad out of memtext. Remember doing something like palette mode and reducing palette color. Pretty sure it's quite a Photoshop feature. Actually, you can do that here. It is posterize, and when you posterize, you can give it the number of layers, or sorry, of. However, when you think about it, I'm pretty sure. In this case, you see what I mean there? The growed, the crap that's in between the traces, it's getting quantized anyway, which I think in this case is not going to help me so much. This is a question for a workflow, really. This is not so bad. But see, I've got some gunky areas here. I like your idea of the posterize. It's actually a workflow I've not tried before. Oops, sorry, wrong. And this is Darrow's suggestion again. Yeah, all this area here is kind of dirty. Let me try to paint for a bit and see how that goes. Okay, let me pick green as a color. And you know what? Let me just try outright tracing this to see if it's any better. All right. All the way there. There, that works fine. There we go. Awesome. All right, this works perfectly. Okay, then let's do blue. Oh, Daru says, no, I was able to pick palette colors and combine them. Oh, yeah. I remember that kind of feature in DOS painting programs and stuff as well. I know what you're talking about. I'm not aware. Maybe there's a plugin that does that for Paint.net. I'm not sure. Yeah, I'm not sure. Oh, here I'm going to make my brush a little thinner so that I don't... see, these are some thin traces there. Let me actually undo this work here and work with a green, green brush. Yeah, thanks. Yeah, I think it'll be pretty fast. Pretty fast work. This is, this. The goal is just to get the logical pin assignments going and everything, and to have this like high contrast view of the board. I think this will be pretty fast to do, and like you said, it'll be functional. There we go. Now let's, I don't know, let's do yellowish. Yellow. Like that. And then like this. Huh! I've got a yellow line segment here. That's not correct. Yeah, I know it's not doing the anti-aliasing properly, but I don't care. Okay, I'm getting somewhere. But I suspect we're going to run out of colors before long. So yellow, then cyan. Alright. Let me check the switches quickly, see what's going on here. Not the switches, the keycaps. Throw out the skirt. Boop. See, I'm popping these off with a blade here. Oh, you can't see. It's a bit of a shame. There you go. See, you just go flying. Other one's over here. I've got these nice keycaps. This paper is the backing paper for the tape. I can throw that out. And I'm going to replace the keycaps here. Get rid of these. Get rid of these. These are now the bestest and most wonderful keycaps in the realm. Let's forget about any other keycaps that were printed before. We are now at war with Eurasia. Alright. Looks good. And now for my next trick. Oh, this is starting to look quite good. But you can see that there's still a gap. Well, it's normal that there's a gap, but the gap is not uniform on either side. It is thicker on the bottom. It's wider on the bottom than it is on the top. Can you really see that on the camera? It's kind of hard to see a little bit, but I think I still need to nudge the switch down just a smidgen. An actual other ½ millimeter. It was off by a millimeter at the start, which is surprising to me, but wait, is that true? Is this? Yeah, that's true. Okay. Ooh, it feels like we're getting somewhere here. It really does. Actually, this chamfer that I put in as well is nice and flush. I think I could make it a little ever so little deeper, but let's see what's going on here. All right, I think this is really turning out good. The depth is nice. The registration is really nice. Yeah, I really like where this is going. Okay, so I'm gonna move the switches a little bit deeper. I think I may have made the tolerances on the keycaps a little too intense. I think I'll probably need to kind of dial that down to the way it was before. But that's fine. This allows me to see actually how, yeah, this is actually a better idea. I can see now where and how the switch is misplaced. Okay, awesome. So move it down by another half millimeter or so. And then I might actually might chamfer this bit. Oh no, that's the ridge. I can't really do that. Oops, lost the keycap. All right, that's fine. Yeah, I really like where this is going. All right. Go back to my desk for a minute. All right. Okay. So before I keep going on the circuit thing, let me quickly iterate on the box here. I know I keep going back and forth, but that's the way you got to keep doing these things with the 3D printer while you wait for them to print. So let me just change this. I said I wanted to move the... oh, that's not right. That's not confusing at all. All right. Wait. I'm not looking at this from the right side. That's what's going on. There we go. Okay, there we go. So 2.2, I said another half millimeter, right? So 2.7. The thing is you can measure these things, but you can't beat actually having it built and fitting in there. It looked to me like it was about a half mil. That's an eyeball measure, but there you have it. And I talked about a chamfer, but I'm not sure. I don't need it actually in the end. To make any other changes, I think this is fine. I want to print another two. A dual one, or can I just print one actually? Let's print two. Okay. Back to Cura. Flush it all. And then can I print this at 0.3? I think I'm going to go with 0.2 for this one. It's a bit more detailed. I've got that chamfer to worry about. I've got the ridges. It's 0.3 is a bit much. Curious, but when you edit a measurement, can't you enter the addition or subtraction instead of computing it in your head? Yes, I could. That's a great question, actually. But as it turns out, the software is a little smart. I think if I go and I actually put, say, for example, 2.2 plus 0.5, like that, it puts in the number, but it remembers the actual formula, which, meh, like both values are kind of arbitrary. I just want the final value. You know what I mean? I don't care. So yes, the answer is yes. You can put in the formula, but it remembers it, which in this case is a little less useful to me. But yeah, for complicated math, you can totally do that. Yep, exactly. So sorry, I was slicing this. Let's prepare it. $12, that looks about right. PCB, blah, blah, blah. Go back to Octoprint. Heat up the machine again. And then get rid of this. PCB 907, that looks right. Print. Yeah, Daru suggests there's probably a way for it to store just the resulting value. There may be. This software has tremendous depth, and I'm far from being a master, so that's quite possible. I'd have to see. Actually, you know what? Let's look. Fusion 360 store equation result. Now I hate doing Google searches on stream, but there you go. Because sometimes somebody has like a better way of looking for something, you know what I mean? I look like an inept Google searcher, which I am. Fusion 260, that's like the previous version, I guess. If I go back into the next, it's 2-inch bore. Expect to see blah blah blah. This way because many times the equation, yeah. Recommend making an idea station post outlining your suggestion. See if it gathers ample support. This is a fairly recent post. Yeah, just replace it with the number. So replace it with the undated number. Use a calculator. All right. Well, I use my mental calculator. Yeah, that's. I won't spend much more time looking at this, but there you go. So it just seems the latest suggestion I saw quickly on the forum was use a calculator. So the heat shroud was, the fan shroud was about to pop off again, so I just reached in there with my finger and pulled the plastic off. Hopefully that won't mess up things too much. Alright, so we've got this underway, back to this outlining. So I've got aqua in there, let's look for the magenta. Okay. I don't think I'm gonna bother with such a complicated, like, crooked design for me. I'm just gonna route everything to the end, put in some holes so that I can solder some wires, and then that'll be that. Call it a day. Now here's the question: do I reuse my colors? Sure, why not? All right, then go back to red. I think it's going to be sufficiently visible. Trace over this just a little bit more. Wow, that printer is noisy. There's one bearing in there that makes noise, and there's a lot of bearings in the printer. There are 1, 2, 3, 4, 5, 6, 7, 8, 8 bearings and 2 couplers. Oh ho! Wait, I missed a line here. Oh, I did. I missed a line there. Alright, so now back to blue. Sorry for Mr. Cranky Pants over there making noise. Hopefully it won't be too bad moving forward. I think it gets less bad as the Z offset gets higher, so as it starts printing more and more high off the print bed. Wow, this noise is terrible. So a lot of people upgraded their bearings. They go to these. I think mine are like metal bearings. They're the cheapest kind. They're the ones that came with the printer, obviously. But I think so. I'm not going to use cyan here because it's going to be right up against the other one. So the trace is going to be right up against the other one. So some people use. I I think they're polymer based bearings, so they're like Delrin and stuff like that. A bit like rollerblade bearings, which are fairly silent. And they're kind of self-lubricating, like as the plastic breaks down, oops, it actually, the dust kind of lubricates the joint, if I'm not mistaken. I'm not an expert in these things. Alright. I like the way this is looking. Alright. So here, see, let's look at it. I've got what? I've got one signal that's shared, this red one here. The cyan one is shared among 3. The green one is shared among 3. Purple is shared among 3. We've got one solo signal, 2 solo signals, 3 solo signals. Yep. I'm thinking here. So there's no reason for me to make this board go any further than here. I could like cut it off here. Oh no, dear. Oh. Ah. I painted on the background. Messiah. I hate it when that happens. When it's 1 or 2 lines, it's one thing, but I painted the whole thing in the wrong layer. Okay, screw it. I'm gonna save this. And hey, look, it's what I want, right? These lines are what I want, so who cares? So I don't care so much about the signals themselves as I do about the separation between the signals. Again, what I'll be placing are I'll be doing what's called the with zero tolerance. You can easily select those lines. That's true, but I've lost the pixel data that was underneath. I'm not even sure really yes, with the wand tool indeed. But I'm not even sure what I do, like whatever. I don't really need the original picture anymore. I have it in the other later if I ever need to. And I also have the original, so well, I'm not sure what I need to do to fix here. Obviously, the programmer and OCD guy in me wants to fix this, but I think I'll just pass for now. So. Let me think about this for a bit. Okay, so I'm going to move this off to my secondary monitor for now. I see Darrow smiling, yes. I'm going to go back here. Ooh, okay, so now this is interesting. I'm going to have to work with a sketch. It's not part of the original sketch, which is good. So the original, so one thing you could do here is I could actually go and edit the sketch and like draw all the switches in here, and then like draw all the isolation routing and stuff like that. But it would get super dirty. Like all these dimensions, like it would just start overlapping, and it would get really kind of painful really fast. So if I suppress this feature, now what I can do rather, is I can actually create a new sketch. Check it out. So I'm going to create a sketch. I'm going to say this sketch's plane is... I'm going to use the origin plane for this because I know it happens to be the plane of the bottom of this thing. But what I'm going to do is I'm going to use the P for project tool. I'm going to project this. That's a lot of projections. I'm going to project this, and I'm going to project this, and I'm going to hide the bodies. So check it out. Now what it's done is it's projected all of these elements into my sketch. And these are actually still linked to the original elements, like the 3D elements. If I go and I change a 3D element, the projection will change as well. Now, as you can imagine, that link is somewhat tenuous. It's not the most robust link ever. I mean, you have to think about how these things work, right? Like if I change a profile or I remodel this thing and it doesn't really exist anymore, well, the projection won't work. And so what Autodesk or what Fusion 360 does in that case is it uses what's called cache geometry. It'll kind of just use the old version of the geometry and then it'll give you a warning, and you can go and revisit that warning and you can correct the problem. And yes. In this case, the geometry is close to final, so I'm going to go ahead and start sketching this. And what I'm going to do is I'm going to start looking at where I would need to isolate my signals. See, there's something with the projection here that I don't really like. Let me see if I can try that again. I'm gonna stop this projection, undo the projection, and instead of projecting the whole face, what I'm gonna do is I'm gonna project the edges like this. See here, it kind of. Oh, wait. Turn off the sketch. Okay, project this edge. Yeah, this stuff, the bottom and top stuff is fine. Actually, you know what? I don't even want the bottom and top stuff. What I want is really the outside. And you'll see why in a second. It's because there's all this noise that I don't really care about. Project this edge too. And then I'm going to go and project just the circles. Oops, that's not what I wanted. That are for the... Is that right? Yeah, that was right. Yeah, just the circles that are useful for the circuit. No, because the plastic bits are going to stick through the PCB as well, so I kind of have to avoid those. Ooh, this is going to be a bit more painful than I thought. Okay, let me undo that, redo it the way I've done it initially, and let's just see where this goes. Sometimes the best way is just to try it out. All right, hide the bodies. Hide the bodies. That sounds like a catchphrase from some kind of bad cop show or something. Okay, so my secondary monitor over here, I've got the diagram that I've drawn, and just for fun, I'm going to try to isolate one of these traces. Okay, so first things first, radius 0.8 millimeters. Okay, so I'm going to draw, I'm really making this up as I go here, I really don't know what I'm doing, but oof. Oof. Oh man, these plastic pins are going to be a pain in the rear. Oh man. What's the distance between this and this? Oh, 1 millimeter? Okay, wait. Okay, 1.6. What was that? 1.6 millimeters. Sorry. 1.6 millimeters. What about this? 1.9. Okay, okay. Sorry, I've got this wrong. Okay, wait. Let me just give myself an idea of what I'm looking at here. Okay, so this is a pretty. So I'm thinking I'm probably gonna use like a 0.5 or 0.6 with trace, but 0.4 would be the best probably if I can pull that off. Not trace, sorry. Isolation groove. Okay, so this is included. This, I'm gonna run it. Wait. It's the right side of this switch here. So something like that. What's going on here? Why doesn't it want to? Okay, whatever. Oh man, these plastic pins are going to be a pain in the rear. Wow. But this is the trickiest part of this. I've actually started with the hardest part. If I can get this part done, then maybe there's hope. Maybe there's hope. Okay, so I suppose, you know, I'm trying to avoid point-to-point wiring, but directly to the switches. But I could actually just, I could kind of go halfway, right? I could do this. I could have just these two pads connected together, and just a wire running here, and then these 3 pads connected together, and just a wire running all the way over here, and so on. It wouldn't be quite as clean. It definitely wouldn't be quite as clean as having all the holes over on this side. Definitely wouldn't. Okay, so let's try. Let's try, just to see. Can I route this? Okay. Now let me just sketch this one out just for fun. Okay, all the way to the right. Oh, that is a long trace. Like this. Okay. And if I offset that by, let me create, say, trace groove width. So 0.4 millimeters, that's not a lot. Groove W. Okay, sketch. Offset. Groove W. All right. I have to route 2 more above this, which seems feasible. Maybe. If I draw a line across this, does it actually consider that as a region? It does. Oh, this is going to be a pain. Okay, so turns out I don't want these ridges in there to begin with. Okay, so can I delete these? I can, but that's going to be too long. All right, screw it. I'm just going to back out. This line is just one line to redo. Okay, do this projection I want. Then I want this, 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 and this, and this. And then cancel out of here, and then hide the bodies. There we go. Okay, that looks cleaner. I need to avoid the plastic pegs, but I don't care so much about the ridges that are on the other side. All right, so let's draw that again. So like this, that, like this, like that, this, and then up between the second and third switches. Did I get that wrong before? I probably did. I think I did, yes. I need to be careful here because I need to route 2 more. So Daryl asked, what's the problem with the pegs? I'm going to try to explain this a little better. Okay, let me switch over to the other camera for a minute. Okay. Okay, so explain the problem with the pegs in a second. Problem with the pegs is if you look at the underside, of this over here, you can see that the pegs, they stick out, right? They stick out as much, pretty much as much as the electrical bits do. And so what happens is when I'm going to be routing these circuits around, these traces around, the plastic pegs are going to be in the way. I kind of got to work around them. My traces have got to work around them. Unless I was to try to cut the pegs shorter or something like that, but that would be like a pretty labor intensive process for both for me and for everybody trying to replicate these results. So I'm going to try to route my traces around the plastic pegs, even though they're in the way. One thing I can do, one advantage I can have, I have though, compared to the original design, is that I can actually route signals here, here, between the plastic pegs. The original circuit couldn't really afford to do that because they had this big, like, touch area that they couldn't mess with. So it's kind of like I'm constrained, more constrained in some ways, but less constrained in others. I hope that explains the problem a little better. So while we're here, let me get the print off the printer. Sorry, I've got limited space to work with here. This was a little damaged. Didn't come out all that great. That's because of my my shenanigans at the start there, where I pulled some stuff off the print bed while it was printing. All right. Doesn't look all that great, but the dimensions look right. So I'd move the switch down a little bit in this design. Let's move the switches out from this old prototype into the new one. Even though it's a little dirty. Ooh, quite dirty actually. Oh, I think there's a bit of a... No, it does fit in. I have to push it in. Be a little forceful with it there, but I'm sure it survived. These things can take a beating. There we go. So Daru asks, why not avoid the whole peg area like the original design, go outside of that area? The reason is simple. I have very, very limited space. If I could expand it and take more space inside the keyboard, I totally would. But I'm right up against the key well on one side, and I'm right up against the edge of the outside edge of the keyboard on the other one. So unfortunately, I'm kind of limited in terms of real estate. This width here is about as wide as I can go without like dremeling out my keyboard or something. And even if I did, I'd gain like 0.5 millimeter or something. So, all right, let's see if this works any better. I think it will. Oh, this looks and feels great. Oh, it feels so good. All right, we're getting there. Let me try all the keyholes just to make sure. Okay, feels great there. No, lost the keycap. See, normal use, I don't think I'll be losing these keycaps because I keep pulling them off when I pull the assembly out of the keyboard. Oh, guys, and girls, this is really feeling super nice. Oops, whatever. I'll put the keycap back in as well. I still need to move the switch though, I think. Or is it that the registration is not correct, or what is it? Wait, did I move it too far down? What did I do there? Yeah, see, I printed these keycaps in low quality and now I'm paying for it. Let me hold this tight with my finger. Okay, yeah, so the switch moved a little too far down, just a smidgen. A very little, very small smidgen. Alright. You see the next hole. Oh, see here it's a little too high. Oh, that's weird. So maybe that the registration is not quite working like I was hoping it would. Maybe there's a flaw in my design. Okay, I think to kind of iron this last kink out, I'm gonna have to go and start printing full-length boards. This is inspiring. You know what? Maybe the key is actually... I think maybe this key could actually afford to stick out a little more in this corner here. It's quite sunken in. I know it's like that on the new version of the keyboard as well, but maybe just a little bit, eh? So what about these? What about these keys over here? Yeah, they could definitely afford to stick out a little more. So what I'll do is I'll now knock down the depth of this thing by a millimeter, and then I'll probably print a full length one. Yeah. But that'll be a bit longer, so I'm probably going to print that like at some other point. What I'm going to do for now, I'm going to keep working on the PCB and maybe print a test for the PCB a bit later on, because I'm pretty sure the print for the full length thing will be like an hour or more. I'm not gonna wait around for that right now. So let's go back to the desktop. So Daru says it's cool because you have the freedom to make those keycaps custom height based on position. Yes, I most certainly could. I could make the inner ones thicker and stuff like that. I happen to know though that both my keyboard's design and the new one, they're not custom based on position. They are basically flat all the way through. Even though the curve, sorry, I'm using the wrong camera, microphone there. So even though the front of the keyboard kind of curves a little bit, the tactile feel is a little off. If the row of keys is not perfectly flat, I think it would feel kind of weird. I don't know. Yeah, you said switch OBS now. Sorry. Yes, I forgot to switch earlier. Hopefully it's better now. There we go. All right. So let's go back to this, this PCB test. Okay. Yeah, see, so this is the size of the whole thing. This is pretty much the area that I have to work with. I wish it was wider. Oh, wait. One thing I could do, though. See, the thing is, I could route this a little simpler. The ultimate is routing it like it was originally. Pretty much exactly, and then every single hole on the right here, where I'm going to have my wires, is going to line up with the signal, proper signal. Now, I could also have it so that, like I said earlier, just route these few signals together, and then have a wire coming out from here all the way to the end, and another wire coming out from here all the way to the end, and so on. That'd be a little less clean. Another thing I could do is to route the signals all the way to the end, but then change the order of the wires, such that, for example, if you're looking here, this red wire here, I could actually just route it on the bottom. I wouldn't really care. But then I'd have to know, there'd be like this opportunity for screw-ups, basically. We'd have to know to connect this wire up here in the third position on the keyboard's motherboard. So again, if I can avoid it, I'd prefer to avoid that. Let me still have a go at this sort of this isolation routing here. So okay, so that's one isolation done. I have this pin. I need to isolate it from, actually, okay. I'm gonna go and for fun there, like that. Does that work? That does work. Okay. So I basically want each little individual region to represent one of my traces, and then I'm going to offset everything, and then we'll see. Okay, so this pin goes to the top. So I could route that, for example, like this. I'm really drawing this freehand right now. As you can see, I'll probably measure things. If this works at all, I'll measure things up and line them up properly afterwards. Save this. Okay, so like that, like that, like that. So if I was to like offset this now, how would it behave? Wait, chain selection. Ooh. Groove. Where's my parameter? Oh wait, sorry, I undid that, eh? Yay! What's the distance between this thing and this thing? 0.4 millimeter. That is not a lot. Okay. Width, and then okay. So see how this region here, well, yeah, this region here and this region here, they're like one trace. This region here is like one trace. This region here for now is like one trace, but not quite right. So, hey man, these are tight tolerances. 0.2 millimeters. Oh. It's a bit close, So I can move this really close to the plastic peg though. Just to look at 0.5 millimeters. Alright, so what about this guy? 0.5 again. Woo! Okay, these are really narrow traces. Well, tell you what, if this works, if this works, we'll know that this technique is roadworthy. Well, this isn't going too bad actually. Let's just keep going. So Daryl asks, will pegs have to go through the PCB too then? Yes, they will. But the reason for that is because when you've got this is the top of the PCB, I need the metal peg to stick through just a little bit so that I can solder to it from on top onto the copper. Now, because we saw earlier that the plastic or the metal pegs are the same length as the plastic pegs, both are going to stick through together. So you're absolutely correct in thinking that the plastic is going to stick through the PCB, which is a bit unfortunate. If both were separate lengths, then that wouldn't be a problem. But yeah, there you have it. This is not too bad. I mean, I think I've got room to work with here. Let's see what I can do with the next signals. So the next one is this guy, just this on pin. I'm going to see if I can't. Okay, so let me undo these offsets here, because I need to do that at the very end, I think. Actually, wait. Is that true? Where's this? Where did the offset? If I delete this, oh, then it just disappears as a constraint, or replace it with a bunch of constraints. Okay. So okay, I'm thinking here. There it says maybe another option would be to make your pins longer somehow. Yeah, I mean, it's not a very common thing to do, I guess. Like if your device, normally devices come with very long pins that, yeah, rather than the peg shorter. So in my case, it would be easier for me. So making the pins longer means soldering something to the pins, which means I have to solder. If I solder something to the pins, I'm just going to make it like point-to-point wiring. I'm basically just going to put the switches in the plastic and solder the wire, you know, solder a wire to all the legs that it needs to go through to, and just be done with it. That's just build like a point-to-point circuit that way. But I was trying to avoid that because it's kind of labor-intensive, and it means that it's more painful for other people to replicate this process later on. I think if I was to make something shorter, it would have to be the plastic pins, but even that, it means filing down like 18 switches per keyboard, and you know, they're not all going to be the same length and everything. So yes, these are all things we could do, but I haven't given up on this idea of trying to route everything properly. So what I was just cool. So what I was trying to think of here is a way to. So the problem I'm having here is now if I want to draw like an extra line here, I like the original circuit line here. The guide for the groove fuel is this line. But if I draw a line here, it's going to create a new region here, like this and like that. What's going on here? Yeah, there you go, like these, which is not really what I want. If I offset this line, then it's not going to give me exactly the results that I want. It's kind of a poor explanation. I'm kind of thinking ahead here because I'm thinking of problems that I had at Halloween. And the problem is this, is if I want to go back to this stage here and then edit these lines, which are the lines that separate each part of the circuit, then once the lines are offset, it becomes a real pain to do this, basically. So what I think I'm going to do is I'm going to draw all my lines in here, and then I'm going to create a second sketch, which is going to be in the same plane as this guy, and then I'm going to fully project like everything, like all these lines here. Can I? Oh, this would be long if I have to do the whole thing there. I mean, not impossibly long, I suppose, but let me just try it out just for fun. Okay, so if I do this and then I hide this sketch, and then can I offset this? Oh man, it doesn't change the selection. Oh. I wish it would change the selection. Okay, so let's. This idea doesn't work. I'm looking for a way to toggle the offsets on and off, you know what I mean? Rather than having to do all this at once, then do all the offsets. And if I ever need to change anything, then I need to really like go back to the drawing board, so to speak. Well, is this really so bad? I have to go back on this. I think this is one of those things I just have to try and see how bad it's going to be in terms of workflow. Yeah, I think my ideal vision for this kind of for these types of printed circuit boards would be to actually take out like a layout from you know, like a Gerbil file from Eagle or KiCad or whatever it is, like you know, open source design tools that are out there, and then and actually convert that to an STL file, so a 3D printable version of the circuit that then you just put the copper foil over it and you run your knife down it and everything works. Now this manual isolation routing is a bit of a pain, I admit. Alright, so the next one is like this. Like that. That's one region, okay. And then the next one is oops, it's a little too long. Like this. This is gonna be so tight. Oh man. And then skip 1, 2, 3, 4, 5, 6th pin. So 1, 2, 3, 4, 5, 6th pin. That. And then all the way to the last pin. So another 1, 2, 3, 4, 5, 6th pin. 1, 2, 3, 4, 5, 6th pin. Like that. That looks correct. Okay. And then the last sort of really tricky case that I've got two tricky cases, but are this pin here. I need to route. Wait. Is that the right pin? Sorry. No, it's not the right place. I drew that line. 2. Wait. It's a bit confusing. 1, 2, 3, 4, 5, 6. Okay, so the circuit's gonna route down here. 7, 8, 9, 10. So 7, 8, 9, 10. This is the pin. And then I have to route it. Oh, this is Is that correct? That's not right. That's not right at all. Oh wait, sorry, it is right. Yeah, that is correct. Yeah, okay, that's fine. Ooh. a brain confuser thinger. And then the next circuit I think I'm going to route is this one, because it's quite simple. Like that. It's the next. Alright. Can I actually delete this projected line? I can. Oh, that's great. And this one too. Alright, much better. This is the next circuit, okay. And the next one is going to be like so. Oops, what's going on there? So I don't even need to do that. That's not doing anything. Thank you. So just need these three together, which is already the case. Okay. Okay, so now I'm up to my next tricky case. So this one was this one, and this one, this peg. It's possible I might be able to make the groove less than 0.4 millimeters wide. I'll have to try different parameters. I'll have to toy around with this. Okay, so the three last ones are tack. This one's my last sort of complicated one. Oof. Okay. No, that's wrong. Okay, sorry. Okay, so this is this peg, and this peg. And now I wanted to, no, so what I'm going to do is like this. Like that. Okay, 1, 2, 3. That's good. 1, 2, 3. This is good. This one's good. Wait. That's not right. That's not right either. Dope. Wait. What have I done here? Okay, I screwed something up. Okay, wait. This is not correct. But it's for sure going to be simply fixed, because this has to go up here. Did I lose a line there? Oh, I think I may have deleted a line. That's what happened. Sorry. This is my bad. Okay, like this maybe. Okay, so this is going to go up like that. Yeah, I think I'm missing a line here that I had before. This is correct. This is correct. don't even need this line at all. Like, yeah, I don't need this at all. Okay. Okay, it's gonna help me. It's gonna make things simpler. So at the peak, I've got 6 traces, which means I need to have 5 lines. Here I've got 6 lines, which means I've got 1 line too many in terms of thickness. If you look here, 1, 2, 3, 4, 5, 6. That is the place where I've got the most traces to handle. So I've got something wrong here. This is progressing well though. I'm almost done, I think. Okay. Yeah, okay, this guy goes up here. This is the green that goes up here. This is the top circuit, top trace rather. This guy is the second one. The third one is the red. The fourth is this guy. Okay, fair enough. Fifth is this guy who, well, I guess this is the inner boundary. Okay, sorry, of the purple one. Okay, so this looks alright. Okay. Okay, so the purple guy looks right. Now this is the red guy. That looks right too. Green guy looks happy. Oh, cyan guy. Wait, sorry, this is cyan guy. Okay. What are these? These are the green guy. Okay. Purple guy. No, sorry, cyan guy. Wait, this is not quite right. No, that's right. That's right. That's right. Okay. And then here I was trying to do blue guy. Now blue guy is just this. That's blue guy. And then this is going to be yellow guy. Alright. This is coming together. And this is purple guy. And I think that's it. Missed the task 10 last minutes. Looking good. Yes, it is looking good. It is coming together. Slowly but surely. I'm sinking further and further into my chair. Sorry about that. This is as I concentrate more and more. Okay, let me try just before I start offsetting these things. Try to like equitably distance them from one another. What's this guy? Okay, yeah. See here, I'm going to trim the constraints were removed. Okay, fine. Just trim that line a little bit there because otherwise it's going to create 2 separate regions. Otherwise all my regions are actually contiguous. Man, gotta be tight. That. I'm really just eyeballing this there to see if there's any way that's going to fit at all. These distances and tolerances. Alright, this one's awfully low. What's the distance here between these two, say? 1 millimeter. Okay, that's quite good. On the bottom side, I've got lots of space. Here I've got 0.6 millimeters, which is not great. Okay, let's save this, and then let's make with the offsets. Ooh, ooh, this is tight. See, here, it's doing something I'm not super fond of, which is creating these little junctions. That's fine. I wish I could, like, offset. Yeah, I don't think I can offset more than one curve at once, unfortunately. Ooh. Can it offset more than one curve? Did I just do what I think it did? Wait. Let me try that again. Okay, can I offset this curve and this curve? Oh, but not that curve. Okay, I see. Okay, sorry. Yeah, this doesn't quite work. Okay, groove width. Groove width. Some serious offsetting going on here. See, get there. Okay, I think I got them all. Okay, so is this correct? Looks like it. And this is correct. And this looks correct. This looks correct. Wait. Oof. I think I broke something with my offsetting here. Oh, no. Sorry, this is the purple guy. Yeah. That's fine. Okay, purple guy. And then this is cyan guy. Red, green. Looking good. Cyan again. Blue. Yellow. Purple. Yeah, blue what we did. And cyan for the last guy. Okay. All right. Okay, so let me just quickly draw an extra, a rectangle here so we can terminate all these properly. Okay. And then let's get rid of this line here. Oops, what did I get rid of there? This line. There we go. Oh, This is slick. Okay, let's look at these widths here. 0.25. Okay, that's way too slim. Let's try to rebalance everything and make sure. Okay, so this can be super close to the post. I don't care. Oh no, that's not true. Yeah, so I don't mind actually that it's close. I think things to try. Okay. I have to change the groove width though. It's gonna make this much. Trickier. Okay, I'm gonna move this up a little bit. What do these dimensions look like? 0.5 millimeters, that's not a lot. Oops. But hopefully these numbers will be enough to get us through. All right. Sorry, I don't have much to say right now. I'm just kind of concentrated trying to get these things moved out as fairly as I can. I could go and trim all these little sections here. I don't know what that would save me is a bunch of time clicking on these little segments that I extrude. Sometimes I forget to click on some when they extrude to create the isolation grooves. But if you trim them, then it starts breaking all kinds of constraints and stuff, so it's kind of a bummer too. To have to do so. Oops. Okay, move this a little further apart. I have all this space here, I mean. All right. So just for fun, okay. Circuit. Box. Okay, now let's bring back the bodies. And what I'm going to do is this very first extrusion here. If we go back in time, it's the extrusion that extrudes the original plate. I'm going to two sides. 1 millimeter on one side. I'm going to give it 0.4 on the other, like that. And then, oh, what happened there? Combine. More info. Tool body error. The tool body is lost. Try editing this feature. Okay. Edit feature. Oh, sorry, that's my bad. Join. Okay, so see, that's an example of it not reconnecting something properly in some operation because I created a new body there when I added. Wait. Wait. Oh my God, the chamfer. The chamfer. The chamfer. No, the chamfer is cutting into the printed circuit board. Okay, that's a challenge for another day. I think what I'm going to do for now is I'm going to suppress the chamfer. Boop. As though it never existed. Problem solved. That means this won't fit inside the keyboard anymore. But that's fine for now. So what I'm going to do now is I'm going to edit this sketch, or sorry, I'm going to extrude, and then I'm going to have to select all of these traces individually. What are these sectors? Because I didn't go and trim. Okay. Because I didn't go and trim anything. But that's fine. It's not too bad, right? There's not that many segments that go and click through. Yeah, that was really painless, actually. Much better than the alternative of trimming everything. Okay. Bring back the body. And then extrude down. And it's going to cut. I love the way this looks. It's going to cut into the face. So now, da-da-da, got this nice little isolation routing here going on. And you can see how this looks with the grooves here. These are the grooves. I'm going to run my knife down this groove. And as a test of this, what I'm going to do is I'm going to actually, you know what? Just for fun, I'm going to unsuppress the chamfer there. Yeah, see on this side it eats into some traces. There's a full trace that I lose here. Oof. Okay, that's fine. That's fine. You know what? Let's just get on with our lives. I'm going to create a cube now. Profile. Sorry, no. Create a cube. A box. In this plane, yes. And it's going to be yay big. Like that. And it's going to intersect sure. No. Okay, one, then feature. Can't move it down. It's kind of weird. Huh. You can't. Okay, never mind then. I'm going to create a box in this plane. And it is large. And it's going to cut. There we go. I wish I could like Alright, take it easy, Daru. Have a nice evening. Thanks for joining in. I'm going to cut into this a little bit more. Just so I have minimal printing time. 0.6 millimeters, that's 3 layers. And this is 1 millimeter full thickness. All right. Save this. And now print this. This is a real test of what's going on there. Get rid of this. Starting to be tired. I think I will probably adjourn right after starting this print. Oops. I haven't even had supper yet. 27 minutes. Oh man, some of these are so thin, but they are there. But they are there. Ugh. These features are so small. See, ideally, I wouldn't impose upon people to use a nozzle other than 0.4 millimeters, anyways. We'll see. We'll see. Oops, it's a little too far off. Prepare this. Save to file. And then, sorry, I'm kind of losing steam there. I'm a little tired. All right, let's get this done. Preheat. Preheat. Get rid of this. Upload. PCB, that's the right time. And it says about half an hour, which sounds about right. This is a fairly big print. Well, big, I mean, not by any standard, but it's going to be longer than the other prints I've made so far on this stream. I think I'm going to call this an evening. I've been streaming for quite some time. I think like 2.5, maybe 3 hours. I'm not sure. I can't remember when I started. But I am pretty hungry by now. So thanks a lot for joining in. I'm going to finish this. I'm going to put the tape on it, see what's going on there, and stream as soon as possible and keep going on with this project. Hopefully I can get all of the isolation routing done properly. And then that would be an awesome sort of proof of concept for this technique of using the copper foil on the 3D printed circuit. And oh, later, yo, Raja. And yeah, starting to come together. I feel like the bracket, you know, with the mounting of the switches, it's at the right depth. It's got the registration in there and everything. And hopefully I can start soldering some stuff together soon. I'll have to redo all of this process for the other side, for the other PCB ribbon like this, but don't forget the other one is simpler. It's got fewer traces and it doesn't have this super high density stuff going on one side of the printed circuit board there. So it should be easier. I think I've started with the hardest part. Without further ado, I'm going to let you I'm going to cut you some slack and don't have to put up with this noise of the printer. And thanks again for joining in. I'll see you soon. Bye.